Good morning, pre-calculus. Today's video is section 9-3, dealing with geometric sequences and series. So, Mudrock, hit the lights. All right, yesterday we did arithmetic sequences, and I don't know if it was also included arithmetic series, but if not, we'll get to it. Today we're going to look at geometric sequences and their series. All right, so the big equation we're going to ask ourselves, how do you find terms and sums of a geometric sequence? Now again, remember, if we go back to an arithmetic sequence, you'll notice that from one term to the next term, it's either increasing by the same value or decreasing by the same value. Now, in a geometric sequence, when you go from one term to the next term, you're going to see a product or a division of the same value from one term to another. Okay? Now, series means if we want to take 5 numbers from the geometric sequence and we wanted to add them together, that will be called a series. So we're going to say geometric series. So how do you find the terms and sums? Remember, sums have to deal with series. Terms deals with what we need to do for sequences. All right. 2 formulas to get us set up is the nth term of a geometric sequence. You'll probably notice that we have 2 of them. Very simple. Your first term of your sequence. What do we begin with? And then the R here is your common ratio. This you'll be able to find by either looking at the problem or have to do a little bit of on the side with a paper and pencil. All right, so we're going to use these 2. This is the explicit rule for the geometric sequence. We're going to use this throughout. Again, we can use both of these. They're both the same. They're just written a different way. So, geometric sequences deal with pages 663 to 665. Follow that. There's quite a few examples to look at. You can work it through as you go along. But I thought, let's do one example. Find the nth term. In other words, I'm trying to find one of these. Find the nth term for the geometric sequence with the first term being 5 and the common ratio is 2. Well, with that said and done, we know the first term is 5. We take 5, multiply it times 2, we get 10. Take 10, multiply it by 2, we get 20. And you see it. That is an example of a geometric sequence. Each term is being multiplied by the same value. So if you go back up here to this problem up here, again, I think I use this one. So if we want to find the nth term of the sequence, well, we know that the first term has got to be a sub 1 will be our first term, and R is your common ratio. Now, this is relatively easy. It's about as easy as the last section. So let's say, for example, we want to find, just for fun, let's say the 27th term of this sequence. Well, it's very simple. A sub n, or in this case, a sub 27, equals 5 times 2 to the n minus 1, which in this case is 27 minus 1 gives you 26. Use your calculator. 5 times 2 raised to the 26. Enter. And that is going to be, what, 300? It's a huge number. That right there will help you find the 27th term of this sequence. All right, let's try another one. Let's say we want to find the 20th term of this geometric sequence. 1, 3, 9, 27. Okay, we already see we started off with a first term. Next thing we got to do is look at and see what the common ratio is. And you're going to notice that from the first term to the second term, it's been multiplied by 3. The second term to the third term, it's been multiplied by 3. And you should see a pattern. So our common ratio is 3. We know the first term is 1. Here is your explicit rule, or the nth term of the geometric sequence. So we want to find the 20th term of this. Just let n become 20. Do your math. Very, very similar to the one we just did a moment ago. All right, that is geometric sequence. All right, Roman numeral 2, unless I have another example. No, I have another example. Problem number 3. Those other ones are pretty much easy Algebra 2 problems, but now they get a little more difficult, okay? Let's find the 15th term of the geometric sequence when they only give us the third term to be 5/4 and the sixth term to be 5/32. That's all they gave us, and we want to find the 15th term. Well, again, there's one or two ways of doing this, but I thought let me just do one thing at a time. Up here, here's the setup. We don't know what the first term is. How do we know the common ratio is 1/2? So we have to go over here to on the side. Well, we already know a to the 6, okay, has got to equal a to the third term times r cubed, okay? Because again, this tells us that this a cubed, okay, that's the third term. So we do a little bit of math. We know we have a to the 6, which is 5/32. We know a cubed, or excuse me, a to the third power, or excuse me, let's do it correct. We know the third term of our sequence is 5/4, and we can figure out what the common ratio is. So here is all the math. Multiply both sides by 4/5. Take the cube root of both sides, so we get a common ratio of 1/2. All right, now this one's a little bit different. We got to find the common ratio first. So now we found our common ratio. From here, we can figure out what the first term of the sequence is by either using the third term or the sixth term. I just happen to choose the third term. So, see, this just means which term am I going to use? I'm going to use the third term. So 5/4 equals whatever our first term is times the common ratio raised to the second power. That's the n minus 1. So I'm using the third term, so 3 minus 1 is 2. All right, from here, we just have to solve for a sub 1, or in this case, this will help us find the first term. So 1/2 squared is 1/4. Multiply both sides by 4. That tells us that our first term, okay, first term, that's the third term, this will be the second, and this is the first term. That tells us our first term is 5. So right here, we know that. There is our explicit rule. Okay, this is, oops, hit my head on my video. This right here is your nth term. All we got to do now is we want to find the 15th term, so we let n become 15. That's where we get this part. And now again, I'm going to show you something, so in case you use your calculator, so it'll be 5 times 1 divided by 2 raised to the 14th power. You're going to get that. Sometimes you're going to have to go, you're going to have to do something to get it in this form right here, okay? Because I don't think Bob's going to have it as this. Try to do it with math. Let's see if I can put it as a fraction. No, it won't work. So you have to figure out, see if this really is 3.05 times 10 to the negative 4. Okay? Well, here's how we can do it. It's very simple, okay? We have 1/2 to the 14th power. So I know 1 to the 14th power is going to be 1. I know that. Power to a power. 2 to the 14th power is 16,384. And then you multiply it times 5. Okay? So be very careful in that area because Bob may have it as a fraction, and you might have done your work and probably got it in decimal representation. All right, the next thing we're going to look at is Roman numeral 2, is finding the sum of a geometric series. Here is that formula. This is a capital letter S. That means summation. summation of how many terms, how many you want to do, all depends on the question. A sub 1 is the first term of the sequence, R is your common ratio, and very important, your common ratio cannot be 1. So here's our geometric sequence. Number 1, we have 0.2, 0.02, 0.002, all the way up. Probably the next one will be 0.0002. And we got to ask ourselves, what is the common ratio? Well, we did this in the last section. One way of doing it is let's clear this, is 0.02, okay, divided by 0.2, and that will give us a common ratio of 0.1. I think I messed up somewhere, but that'll give you a common ratio of 1. So that's where this came from. All right. First term of the sequence is 0.2. Again, what I did is I tried to do a little bit of using the calculators. I just left it as simple as possible. So 1 divided by 0.1 raised to the 20th power is going to give us 1. 1 take away 0.1 is 0.9. Again, doing this thing without a whole much of the calculator. Okay, now this is, the key on this word is finite. In other words, I am just finding the first 20 terms of this geometric sequence, and I just want to find out what their summation is. So in other words, if I take 0.2 plus 0.02 plus 0.002 all the way up to whatever the 20th term is, I'm going to get 2/9. Okay, or 0.22222 repeating. Okay, that is finite. Now Roman numeral 3 is another example. This one is an infinite. In other words, if we were to take, as a matter of fact, if we were to take this sequence of numbers, 5, 0.5, 0.05, 0.05, and go all the way up to infinity and add up an infinite amount of infinite amount of terms, this is going to tell me that my geometric summation will be this value right here, and we use this formula right here. So we need to know what the first term is. We need to know what the common ratio is. Okay, once again, to find the common ratio here, let's clear my screen. Take 0.5 divided by 5. I get 0.1. You can go over here, 0.05 divided by 0.5. I get 0.1 also. 0.005 divided by 0.05. And you notice that they all have the same ratio of 0.1. So our common ratio is 0.1, and just do math. That's it. Nothing fancy. So in other words, if we were to add up all these numbers in this geometric sequence all the way up to infinity, its summation will be 50/9. 50 divided by 9, and it looks like it's 5.5, and the 5 is repeating. All right, that is section 9-3. How do you find terms and sums of a geometric sequence? Just remember the rules. Get them written down in your HT&Cs. Something for you to remember for quizzes or tests and homework. Thanks, guys. Catch you later.